Let's try to find a rational function that has the following characteristics. Remember, we're going to go through these. We're going to first figure out if they go in the top of the fraction, so the numerator, or in the bottom of the fraction, the denominator. So x-intercepts come from the top, or the numerator. I'm going to call that the num. Vertical asymptote come from the denominator. We have a horizontal asymptote of y equal to 6. Because we have a horizontal asymptote of y equals some number, not a slant asymptote, and it's not 0, we know that the degrees must be equal. Okay? Again, because we have a horizontal asymptote and it's not y equal to 0, the degrees must be equal. If the horizontal asymptote was y equal to 0, then our denominator would have the bigger degree. And our last part, the y-intercept at negative 45 over 8. And the last part, the y-intercept at negative 45 over 8, you may be going, well, that doesn't go into the top or bottom. And you're right. It's not like the x-intercepts. But what we do know is how we find a y-intercept. We plug in x equal to 0 and solve. So once we get our equation or our function, if we plug in 0, we better get negative 45 over 8 for our y-intercept. So let's go back and figure out our factors. We have x-intercepts at 5 and negative 3. We have an x-intercept at x equal to 5. That means his factor is x minus 5. We have an x-intercept of negative 3. That means his factor is x plus 3. We have a vertical asymptote of x equal to 4, which means that our factor is x minus 4. Okay. Since we just figured out what goes into our numerator and denominator, let's go ahead and start crafting our function. I'm going to make mine f of x. Then give myself a giant fraction. All right, numerators. We said that the x minus 5 and the x plus 3 came from the numerator. Those were our x-intercepts. And then we had our x minus 4 in the denominator. Notice that our horizontal asymptote of y equal to 6 said that our degrees must be equal. Right now, the degree of the top, or the numerator, is degree 2. And in the bottom, our denominator, the degree is 1. And right now, that's not equal. We cannot put in a new vertical asymptote. We can't put in a vertical asymptote that they didn't give us. But we still need to make the degrees equal. We're going to leave the numerator alone because it had the bigger degree. We're going to change the denominator. The denominator was x minus 4, but we needed to have degree 2, so we're going to put a square on its factor. So now that the degrees are equal, we can put in this horizontal asymptote. If it's y equal to 6, That came from y equal to 6/1 if we wanted a fraction, because all of our non-zero answers came from fractions. And we would have 6 up top. If you want to write the 1 down below, you can. It's not required because we don't normally write the leading coefficient of 1. Now that we have the vertical asymptotes where they belong, the x-intercepts where they belong, we have the degrees equal, we have the correct horizontal asymptote, we need to check for the y-intercept. And remember, we need to plug in x equal to 0. So let's check it. We're going to have f of 0 plugging into my function. My 6 is going to stay the same. I'm going to have 0 minus 5 instead of x minus 5. 0 plus 3 instead of x plus 3. And in the bottom, we're going to have 0 minus 4 quantity squared instead of x minus 4 quantity squared. Let's go ahead and start simplifying some of this down. Up top, we're going to have 6 times -5 times 3, because 0 minus 5 is -5, 0 plus 3 is +3, all over -4 squared. If we do the individual steps in our calculator, the top will get us to -90, because 6 times -5 is -30 times 3, all over +16. And you may be thinking to yourself, great, so we messed up somewhere. That is not the -45/8 we were supposed to get. But remember, you always want to simplify your fractions. Both the numerator and denominator are divisible by 2 as a GCF, or you could just use your calculator. Do the simplification, convert back to a fraction. We wind up with that -45/8 that we were looking for. So we've found our rational function. It's f of x equal to 6 times x minus 5 times x plus 3 all over x minus 4 quantity squared. And here the y-intercept was just to make sure that we were on the right track. If you hadn't have put the square in that denominator, we could not have gotten the y-intercept that we needed.